Hello and welcome to another video in the series where I take a look at previous games that I've made and share a bit about the sort of design processes of them, take a dive into the code and how some of the systems were set up, and make a bunch of that code available. So let's dive on in. This one is not a coincidence of when this video is coming out. This was a small game that I made a while back that was a Christmas-themed game. So it's Showdown at the Candy Cane Lodge, and we dive on in and take a look. How things start out is we get this message about this hot chocolate and mentioning of primary and secondary fire, and the reason for that is we have a candy cane gun that is able to launch primary fire and a secondary fire that does a little bit more. And we are guarding the top of a gingerbread house. And coming from different directions, there will be a bunch of very, very hungry snowmen that are set on basically eating the entirety of the house. And the way that I've got it set up is there's a lot of different locations it can spawn from. The environment is intentionally very, very sort of, windy, and I wanted it to have a, while it's not how it feels for an Australian winter, that more sort of, I guess, stereotypical winter feel that we expect from movies. So we have different waves of these folks that'll spawn, and when the gates and the fences are intact, they will prioritize heading towards the gates, and their goal is to try and essentially chew through them to get their way in, like that. And it gets very messy if any of them manage to make it in, because it gets immediately very difficult. Like, you can't see them because you're locked into being on the roof here. And what will happen is they will happily start eating away. I don't think I got all of them. So what will actually happen is parts of the house will fall because there are candy cane supports, and they're just going to start demolishing them. Now, the waves do vary in terms of where they're coming from, so it's something that intentionally does get quite a bit more difficult over time. But if I actually manage to survive long enough, which can't guarantee, we do have some different varieties of ones that will come through. And I need to check to make sure there's not ones destroying this side here. If I manage to survive long enough, might be able to actually see there are weapon upgrades that do spawn in time with the waves. So as you manage to spawn enough, need to move out of that way. So we can see one of the sections of the house has been eaten here. So obviously if you're on a section that gets destroyed, then it will wipe you out also. So you need to be careful of that. It gets very dangerous very quickly. And they do start coming from different locations. The strengths of the enemies does change. So it is sort of your classic scaling up of difficulty that happens with these ones. So do need to be a little careful, because I've already lost, whoops. I think I have it random of where different ones spawn from. I'm likely to, whoops. Okay, so that's a case where that side is going to inevitably fall. And so we can see there's some higher tiered ones coming in now. That's why they have the sort of radioactive glow there. And yep, a section just collapsed. So later ones are a lot tougher and will take a lot more to be destroyed, but we do get different upgrades that will do stronger amounts of damage. So each weapon ends up doing progressively more. And so like of this one, its alt fire is now quite a large area. And so it means that when we get higher tiered ones, it's it becomes a little bit more balanced in terms of your chances of succeeding. And if I switch over to the scene view, so if I go to the scene view, then we can see, okay, sections collapsed, more of it collapses. So that's what happens when you don't manage to do a successful job of destroying them all. And if we take a look at the sort of setup of the level itself, so all of these are individual sections. It's built so that because it collapses in essentially these vertical columns, I have those game objects grouped, and I do have this death line, which as soon as the player goes below that point, then that triggers essentially the game over. So we have different spawn locations. So we have northeast, south, and west, and those all have a light at them just to draw attention to them so that it guides the player to where you expect to be having things coming from. However, there is quite intentionally the snowmen are a very light, bright color so that you'll get a little bit of silhouetting there, but they are still a bit more difficult to spot because it's intended to keep the player on their toes. We have fences are all separately grouped there so that we can actually keep track of them. The gates are separate again because the gates in particular are things that the AIs target. And then our general sort of logic, we have our available targets that we can be tracking that our AIs are monitoring. We have different waves configured. So I set this up so that my waves were defined in data. And if we go and take a look at what those waves look like, what we have is, okay, well, which location it's coming from. So some of them can have multiple and it'll randomly pick. The first wave always comes from the same location. But what this allowed was could have a bit of an escalation in terms of when you'd encounter particular ones where they would be coming from, of what things we wanted the player to have to sort of keep on top of. Have general delays that can be controlled with this, and then the actual spawning config. So it was set up where we can define these different elements of what gets spawned, and we could increase and decrease the number of these. So an element was if I look at the wave 12 is probably a good example because it's kind of the most complex. So it has 5 elements to it. One of those elements is one of the boss tier ones, and so a mini boss and a full boss. There's none of these augmentations. We have then in the second element that has another couple of ones, so that has a tier 2 one. So these all have different weightings of what stuff will get spawned. So each element there has different sets of ones. The element 3 has the mini sort of snowman, so a lot of different ones sort of set up here of different configs of what can actually be spawned. And so in terms of the actual code of starting to look at these, of how these worked, for the actual waves themselves, there was a couple of little helper things for being able to check if it had bosses, for normalizing thresholds, for grabbing enemy configs. So just sort of general little helpers there with it. Most of the logic, though, if we then take a look at the things that it was spawning, because I data drove the types of, or the configuration for the AIs as well. So these had controls in terms of, okay, well, what prefab would they use, their hit points, it would flag if it was a boss. We had controls for sort of the attack rate, things like if that's the amount of damage, crit chances. So a few basic mechanics there in terms of with the attacks. Don't know if any actually used the augmentations. I think augmentations was one of those things that I ran out of time for getting set up, and it felt not good with some of the testing, because I was looking at augmentations like a stealth one, and yeah, that was not really sort of fitting nicely with the gameplay. But so the enemies were data driven, and again, the config, it's just scriptable objects. If we had multiple prefabs, it was randomized of which one it would sort of come back with. So quite straightforward in terms of the sort of configs there for the enemies. Behavior-wise, there's a little bit more there involved, but still very rudimentary behaviors. So we had a concept of squads, so they would be spawned as a squad. Squads had particular states that they were in, that they would switch between, and we were actually, that sort of squad object that was spawned was keeping track of all of the members that were there and whether they were, destroyed, whether they reached their destination. And that sort of kept information like, okay, what's the sort of overall location? Do we need to be searching for a target? In terms of how that sort of went for searching for a target. So the squads drove that logic of picking targets. They would go through the available targets that our AI manager kept track of and look for the sort of closest ones. If there were gates there in particular, they would prioritize trying to actually get rid of gates because that would clear the path for other AIs being able to move through. And then once they had done that, they would go through, after clearing a gate, they would be going and clearing a foundations. So it made it nice and easy for them being able to figure out what stuff to actually approach. So that worked nicely. This move to terminal range was just moving them to particular attack points if they could. Each member would get an attack point assigned. So we'd go and find the available attack points for a particular target. So if we look at something like one of our gates, so like our north gate, it has a whole bunch of attack points that will get generated for it. And we don't see any there at the moment, but if I run this, then pause it, we can now see for that gate, there are a whole heap of attack points that are generated. So if we take a look in our scene view, you can see that, and while it's hiding these, if I get here and turn them on, which it's generated quite a lot of attack points. So if I turn on like of the cube ones, then we have a line of attack points there around the gate that it can be attacking it from, so things right near it. And we have then a bunch of spheres as well for if it needs further sort of points for actually standing at, which we can see further rows of those so it can be in formation essentially. So squads would handle assigning where they're trying to attack, and they would handle assigning the actual individual attack points, which were generally sort of randomized. So that worked nicely, and we had this idea of frontline, which were the square ones, versus non-frontline ones, which were the spheres. So that worked nicely. We had damage logic in that if we needed to. We kept track of what squad members were around, if they'd been destroyed, if we were attacking, and so we had a point locked, then that might now be freed up. So we had logic to go and see, okay, can we move someone else in for now attacking? So just to sort of keep pressure on the various attack targets there. So simple logic, but it made for the AI looking a little bit more involved than it actually really was. At its heart, it was very simplistic logic of randomly picking things, but weighting stuff based upon priorities of like, okay, gates are more important initially than going for foundations and having the idea of front and back line ones. So that worked nicely. The AIs themselves, they again had some state logic also. Could keep track of whether they were allowed to move. So basic logic that was there interfacing with the Unity navmesh system. We had some general stuff there for movement logic. Attacks had cooldowns. We had damage intervals. We could do stuff in terms of applying status effects to ones. So that was things where different higher tiered weapons could cause things like burning or stunning or slowing. So that was in particular on the alternate fires for them, that they were able to apply status effects to things. So that worked nicely for them being able to have damage applied. So some general logic for status effects and for driving the behaviors. And then a lot of stuff was driven via our game manager, unsurprisingly, which that just sort of kept track of our general states for advancing between if we were showing new weapons. And in terms of our weapons, we actually had quite a few ones set up. So there's 3 tiers and each one had alt fires. So we had our hot chocolate. The bomblets one was there as the sort of secondary fire. So the primary fire had a link to information about things like the secondary one and stuff like that. So we had flavor text for all of them. It had details in terms of, okay, what was its behavior? Was it exploding? Was it more of a cluster explosion? Amounts per cluster, what sort of things it would spawn. And so we can see, with our alternate fires, that sort of more setup there of clusters being configured and what things it was actually spawning. And then the highest tier ones were doing even more again, and they had more in the way of status effects. So higher tier ones were doing a burn and a slow. And then with the alternate fire, we'd find it was having all of the status effects. So if you got to the point of having the final tier weapon, you were able to be inflicting a fair amount of damage and had a lot of control there. So that worked quite nicely. The AI manager did a lot of heavy lifting because that was keeping track of various health scaling. So we had general stuff for being able to scale up health. So if you spawned a lower tier enemy in a later wave, it could actually scale up the health of that enemy to sort of keep them still competitive, which is kind of a good approach if you're doing these sort of wave-based shooter ones, that you generally want to have some consistency to what happens, but then also have an escalation to it. So being able to tune things like health multipliers, being able to scale each wave in terms of attack rates can be really handy. So nothing too sort of complex with this. This handled the setting up of the different waves and triggering if we needed to show the new sort of weapon info. Spawning things, we could register that, sort of created the squads, and we could register our targets. So all of that was sort of general, straightforward logic. Our building pieces, Also data driven. This entire game was heavily data driven. So our gates had hit points, they had behaviors for how they collapsed, they had mass that would apply to the physics side. They would indicate if they could kill the attackers on destruction, because things like our various floor pieces and that, we might want them to. So the foundations, when they were collapsed, they would just disappear, but they would also destroy any attackers. So what that meant was F1s got under the house and were attacking, then when they successfully destroyed one of those columns, they would also get destroyed too. So none of these others would cause that, but they did all have, where necessary, things like hit points and mass, and that was able to be made use of. So our building piece here, this would be our generation of the actual attack points. So the attack points, that gets set up when it actually launches. So if it was attackable, it'd get registered automatically as a target. If it was attackable, we would go through and generate those marker locations and add in those attack points and indicate whether they could be attacked from. Because we only had melee characters, it meant that that was essentially the difference. Frontline was something where you could perform a melee attack from. Non-frontline, you couldn't perform a melee attack, so you couldn't do any attacking at all. But having the building pieces themselves keep track of this info meant that I didn't need to go and mark it up, and I was able to essentially procedurally generate it at runtime by just doing a raycast, which would mean if I changed the environment, then that would also work, because I could, if I'd put something that was an obstacle there, then it could eliminate that obstacle as being a location where you could put an attack point, because it was specifically making sure that it was impacting with the ground when it was doing those checks. So really handy from that point of view. So again, nothing too much sort of to it. It just kept track of different modes. So lots of data driving, lots of keeping track of different modes, and a little bit of stuff for when it needed to explode. It could throw things in a bit of a direction, which always was sort of, good for making it look nice. And really, that's sort of a large amount of all there was to it. Like, from the player point of view, the player logic is pretty straightforward. Like, we can take a look at things like the player projectile, and there's very little, because it's just got some very simple bits of behavior of what it needs to do. So we have, some ones that do periodic raycasts and they detonate at a certain height. We otherwise just have general logic for detonation that would do random bomblets off in different directions, and it would look for things that were or weren't the enemy. It only cared if it was the enemy, but nothing too involved in terms of its behavior. The launcher itself, also very simplistic in terms of what it needed to do. Had cooldowns, we could change the ammunition. That logic was straightforward. And we had our scriptable objects for the ammunition that just had our status effects. Again, heavily data driving everything and also making it easy to extend if I needed to. So I could add in additional waves purely with data. Unless I needed different behaviors for any of them, it was just data that got set up. New AIs, apart from the visual model of what I might need there, everything is just data. So that kept it a lot simpler for being able to actually work with it and let me iterate on it. So wave spawners, if you're wanting to sort of experiment with data driving something and get some, something that's a good test case for doing that, a wave spawner based game is a really great one for that, because there's so many good opportunities to data drive And it's one where you can then, by data driving it, it's really easy for doing a lot of balancing and tweaking with it, which is also really good practice to be getting. So it was a good genre for sort of working with, and I really enjoyed that process for it. I think in terms of things I'd do differently in future ones of similar stuff like of this is data driving it was absolutely the right move. But I think what I would do is I would look at ways of having more of it be able to be configured in things like spreadsheets or tables, something like that, so that I can more easily compare the different ones. Like that would make it a lot easier if I was comparing across the different AIs, comparing across the different waves. That would have made it much easier to figure out what was actually sort of happening and tweak and adjust things there. So that would have been a big thing that I would do differently in future ones, is make use of spreadsheets and like that with it for that process. So that was sort of from the data side of things. And then if we look at things like the spawners themselves, there was really not a lot, again, to them. Again, we did a similar approach with this to things like the generation of the attack points. The actual spawn points were generated in a blocking around each individual spawner when it actually ran. This made, again, the idea behind this was, and if I run it and pause it, we can see those spawn points that will be generated. The reason for it was it made it much easier for if I was messing then with the actual terrain itself. So that is currently very, very, very bright. And if I look and turn these spheres on, turn them back on, and let's turn off lighting so we can actually see. So these are the spheres that were getting generated around the spawner. So every spawner would have this. So it just made it that if I moved that spawner, if I changed the terrain, so if things like if these trees got in the road, then I would only have the spawn points that were absolutely valid. So just a handy way of actually making it work nicely. In terms of the terrain and things like that itself, this was one that I set up using Gaia. So for the actual central area here was just made super flat. And I just tried to make it that there was some valleys that led through, and I cleared out sight lines so that when AIs were spawning, you could easily figure out, hopefully spotting them against the background was the goal there. And that's really all of the key bits to the particular game. There wasn't anything really further on than that. Like I said, lots of data driving, but otherwise relatively simple systems. And I'm going to make a bunch of this code available. So that's something that if you're wanting to take a look at some of those systems, like stuff like the attack point generation or the attack point assigning, some of that squad logic there, could be areas that you might be interested in checking out. But all of that will be available. With that code, obviously a bunch of this I'm making use of a third-party audio library called WWise. So there are going to be sections of that code that without WWise installed won't actually compile. This is also from an older version of Unity, so there are sections there that may need to be updated if you're wanting to use those in a newer version of Unity. It's just stuff to be aware of if you're looking at that code. Thanks, folks. Hope you found the video interesting and helpful. If you have, try and like and subscribe. It really helps out. It's really appreciated. If you are looking for the code for the project, that is available up on GitHub, and there is a link to that in the description below. If you have any questions, you can chuck those in a comment also. And with things like the code for this, you can use that in any of your own projects, commercial or non-commercial ones. And if you're looking for other ways to support the channel, then I do have a Patreon, and there's a link to that in the description also, and I have YouTube thanks enabled too. But until next time, bye.